We're going on a trip in our favorite rocket ship, zooming through the sky, little Einstein.
Good day! Welcome to Little Einstein. Are you ready to learn something new? For this episode, we are going to talk about ground improvement. What is ground improvement? Ground improvement is a technique that improves the engineering properties of the treated soil mass. Usually, the properties modified are shear strength, stiffness, and permeability. Ground improvement has developed into a sophisticated tool to support foundations for a wide variety of structures. When properly applied, ground improvement often reduces direct costs and saves time. Ground improvement is divided into two: chemical stabilization and mechanical stabilization. What do these mean? Let us begin with chemical stabilization. Chemical stability, when used in the technical sense in chemistry, means thermodynamic stability of a chemical system. Thermodynamic stability occurs when a system is in its lowest energy state or chemical equilibrium with its environment. Chemical stabilization is divided into three techniques: lime stabilization, cement stabilization, and fly ash stabilization. Lime stabilization is the incorporation of lime into soil. Lime stabilization is applicable to far heavier clay soils and is less suitable for granular materials, and second, it is used more widely as a construction expedient, that is to prepare a soil for further treatment or to render a sufficient improvement to support construction traffic. Quicklime or lime slurries may also be used for excessively wet or dry conditions respectively. It is therefore a very versatile stabilizer. In roads, lime stabilization is widely used for sub-base construction or subgrade improvement. Nevertheless, there is no sound reason why these roles should not be interchangeable. Moving on, cement stabilization of soil is done by mixing pulverized soil and Portland cement with water and compacting the mix to attain a strong material. The material obtained by mixing soil and cement is known as soil cement. The soil cement becomes a hard and durable structural material as the cement hydrates and develops strength. Cement stabilization is done while the compaction process is continuing. During the compaction process, we use some amount of cement. Some void space can be found in soil particle. When we add water to the compaction, the cement reacts with water and become hard. So unit weight of soil is also increased. Because of the hardening of the cement, shear strength and bearing capacity will increase. And because of the stabilization, permeability of the soil may decrease. Fly ash stabilization. Fly ash can be used to enhance and stabilize bases, subgrades, and embankments, and to control shrink or swell properties of expansive soils. Fly ash can also be used as a drying agent to reduce soil moisture contents, to permit compaction and avoid delays in construction during periods of wet weather. The primary reason fly ash is used in soil stabilization applications is to improve the compressive and shearing strength of soils. Typically, stabilized soil has a depth of 6 to 12 inches.
Mechanical stabilization. It is a combination of two operations. In the first operation, the composition of the soil is changed by addition or removal of certain constituents, whereas in the second operation, the densification of compaction of soil is done. The purpose of the mechanical stabilization is to have the soil that can provide effective resistance to the form and displacement of the soil under loading. The mechanical stabilization has been largely used in the construction of cheap roads. If the soil from one source does not meet the gradation and plasticity requirement of a job, it becomes necessary to mix materials from one source from obtaining the desired mixture. The blending of materials can be carried out by making trial combination. Proper compaction plays a very important role in stabilization. Compaction has a great effect on soil properties, such as strength and stress grain, characteristic, permeability, compression, swelling, and water absorption. The properties of a soil under compaction depends upon the water content, amount of compaction, and the type of compaction. Compared to coarse-grained soil, the properties of fine-grained soil are affected to a greater extent by the placement condition. Mechanical stabilization is divided into 5 methods: vibroflotation, dynamic compaction, blasting, precompression, and sand drains.
Vibroflotation, also called vibrocompaction. It is a method of improvement of non-cohesive soils by rearranging the grain distribution pattern while applying cyclic vibrations which cause the outflow of granular soil. As a result, the compaction of soil and the pore volume reduction are obtained. The term vibroflotation is often used interchangeably with vibrocompaction in the literature. However, vibrocompaction is a broader term that encompasses 2 different techniques. The first is vibroflotation, which uses a vibrofloat that vibrates horizontally. The second utilizes a vibrating probe which vibrates vertically. It should be noted that vibroflotation is used as a mechanism for implementing vibro replacement, a method which combines the technique of vibroflotation with gravel backfilling in order to create stone columns. We have 3 types of vibroflotation. First, vibrocompaction method. Second, vibro replacement method. And the third, vibro displacement method.
Blasting. There are 3 types of blasting: abrasive blasting, blast furnace, and rock blasting. Abrasive blasting is the operation of forcibly propelling a stream of abrasive material against a surface under a high pressure to smooth a rough surface, roughen a smooth surface, shape a surface, or remove a surface contaminants. The types of abrasive blasting are wet abrasive blasting, bead blasting, wheel blasting, hydroblasting, microabrasive blasting, automated blasting, dry ice blasting, and Bristol blasting. A blast furnace is a typical metallurgical furnace used for smelting to produce industrial metals, generally iron, but also others such as lead or copper. In a blast furnace, fuel, ores, and flux are continuously supplied through the top of the furnace, while a hot blast of air is blown into the lower section of the furnace through a series of pipes called tuyères, so that the chemical reaction takes place throughout the furnace as the material moves downward. Drilling and blasting is the controlled use of explosive and other methods such as a gas pressure blasting pyrotechnics to break a rock for excavation. It is practiced most often in mining, quarry, and civil engineering such as dam or road construction. The result of rock blasting is often known as a rock cut.
Dynamic compaction. It is a method that is used to increase the density of the soil when the certain subsurface constraints make other methods inappropriate. It is also used to increase the density of soil deposits. The process involves of dropping a heavy weight repeatedly on the ground at regularly spaced intervals. The weight and the height determine the amount of compaction that would occur. The weight that is used depends on the degree of compaction desired and is between 8 ton to 36 ton. The height varies from 1 meter to 30 meters.
Precompression. The precompression technique is a highly effective and economical means for improving subsoils beneath structures and embankments. However, it is often requires considerable time from months to a year or more, and its possible use must be anticipated during planning stages of a project. Precompression is not well suited where local concentrated loadings are high. Precompression is an effective means for eliminating, in advance of construction of a structure or roads, primary consolidation and a portion of secondary compression that is avoided by compression can be estimated and reasonably well, and the surcharge field designed to reduce remaining secondary compression settlements to the tolerable amounts. Observation and confirmation of design assumption during construction should be regarded as essential extension of the design phase. The combined problems of stability, settlement magnitude, and time rate, and of post-construction settlement from secondary compression make pre-compression design about as demanding as any problem normally encountered in foundation engineering.
Sand drains is a process of radial consolidation which increase rate of drainage in the rate of drainage in the embankment by driving a casing into the embankment and making vertical boreholes. These holes is backfilled with suitable grade of sand. Process of construction of drains. The driven casing is withdrawn after the sand has been filled. A sand blanket is placed over the top of the sand drains to connect all the sand drains. To accelerate the drainage, a surcharge load is placed on the sand blanket. The surcharge is usually in the form of dump soil.
Boom! Tapos!
Bye!